We're going to start this video with problem 3 in the 5.3a notes, okay? So again, we're graphing functions with a specified domain. We're going to evaluate the functions for those values. We're going to construct a table of values, and we're going to plot those ordered pairs from our table, okay? All right, so let's look at problem number 3 here. All right, so the function is y equals 1/2 x plus 6, and the domain is -2, 0, 2, and 4, okay? So we're going to plug those values in. Remember, the domain goes along with the x value, so -2, 0, 2, and 4. All right, so we're going to evaluate the functions for those values. So when x equals -2, we plug that in, okay? When you multiply half times -2, you got a positive times a negative, so that's a negative. The 2's cancel out, so half of 2 is 1, so it's going to be -1, okay? Then plus 6, -1 plus 6 is +5. So when x equals -2, y equals +5, so my ordered pair is -2, 5. All right, let's evaluate the same function for x equals 0. Okay, so remember, anything times 0 is 0, so that's going to give us 0 plus 6, which simplifies to 6. So when x equals 0, y equals 6, so our ordered pair is 0, 6. Okay, let's continue here. Let's plug in 2 for x, so we get 1/2 times 2 plus 6. Well, half of 2 we know is 1. 1 plus 6 is 7. Okay, so when x equals 2, y equals 7. And my ordered pair for this input, this x value, this value from the domain, is going to be 2, 7. Okay. Last one, when x equals 4, we plug that in. Well, I know half of 4 is 2, so that's going to give me 2 plus 6, which simplifies to 8. So when x equals 4, y equals 8. So the ordered pair that corresponds with that is 4, 8. Okay. So we're going to plot these 4 points, and that'll be the graph of the function y equals 1/2 x plus 6 with this specified domain. Okay, so the graph of the function in number 3, the function's y equals 1/2 x plus 6. The domain was -2, 0, 2, and 4, okay? So that gave us an ordered pair, a set of ordered pairs of -2, 5, 0, 6, 2, 7, and 4, 8, okay? So -2, 5. We're going to go left 2 and then up 1, 2, 3, 4, 5. We're going to put a point there. Okay. All right. The next ordered pair is 0, 6. So don't go left or right any. Go up 6 and plot the point. The third point is 2, 7. So right 2, up 7. And then the final point is right 4, up 8. Okay. So that's going to be the graph of function in number 3, y equals 1/2 x plus 6. So pause the video and let's try number 4 here. The function is y equals -3/4 x minus 3. The domain here is a little different. The domain is specified as -4, 0, 4, and 8. So you're going to want to plug these 4 values in for x to find the output y, and then create your ordered pairs here, okay? So pause the video, give this one a try, and then come back and check your work. Okay, so first thing, when x equals -4, all right, we're going to plug that in. So we get -3/4 times -4 minus 3, okay? So negative times a negative is a positive. We know that first. These 4's are going to cancel out, so that's going to leave me with a +3 for that part. Okay, so this is 3, and then -3 gives me a y value of 0, okay? So when x equals -4, y equals 0. And that corresponds to an ordered pair of -4, 0. All right, when we plug in 0, so when x equals 0, we get -3/4 times 0, which is 0. 0 minus 3 is going to be -3. So when x equals 0, y equals -3. Okay, so my ordered pair is 0, -3. Okay, now let's plug in 4. When x equals 4, so I plug that in, -3/4 times 4 minus 3. Well, these 4's cancel out, so that leaves me with -3 minus 3, -3 minus 3, and this simplifies to -6. So when x equals 4, y equals -6, which gives me an ordered pair of 4, -6. Okay, last one, when x equals 8, so we're going to replace x with 8. So this is going to cancel out, and it's going to leave us a 2, okay? So negative 3 times that 2 is going to be negative 6. Negative 6 minus 3 is negative 9. Okay. Another thing you could do here, if you want to, you can multiply negative 3 times 8. Well, that's negative 24. That 4 is still in the denominator, so negative 24 divided by positive 4 also gives me that negative 6. So there's a couple ways to get that negative 6 right there. But either way, we're going to subtract 3 from it, which gives us negative 9. So when x equals 8, y equals negative 9, which gives me an ordered pair of negative 8, negative 9. Okay. So let's plot these 4 points so we can graph this function with the specified domain. So the function in number 4 was y equals negative 3/4 x minus 3. The domain that was given to us was negative 4, 0, 4, and 8. Okay. When we evaluated the function for those 4 x values, we got these ordered pairs. Negative 4, 0, 0, negative 3, 4, negative 6, and 8, negative 9. Okay. So let's plot those points. So the first one, negative 4 means left 4 units. Don't go up or down any because the y-coordinate's 0, so that's that ordered pair. All right, next is 0, negative 3, so I'm just going to go down 3 units and put a point there. Next ordered pair is 4, negative 6, so right 4 units, down 3, 4, 5, 6. Okay, and then the final point was 8, negative 9, so right 8 units, down 9 units. Okay, so there's the graph of that function. Y equals negative 3/4 x minus 3. And finally, let's do number 5 here, okay? So pause the video. This function is a little different. Notice we've got an exponent this time, so this is going to be a different type of function. So the graph is going to look different, okay? So we've got the function y equals x squared minus 4 for the domain negative 2, 0, 2, and 4. So we're going to plug those values in for x, and we're going to see what we get out for y, okay? So pause the video here, give that one a try, and then come back and check your work. All right, so first thing we're going to do when x equals negative 2, so we're going to plug that in. Remember your order of operations, negative 2 squared, we got to do that first. So that's going to be positive 4, and then take away this 4. So 4 minus 4 is 0. So when x equals 2, y equals 0, which gives me an ordered pair of negative 2, comma 0. All right, let's plug in 0 for x. When x equals 0, I get 0 squared minus 4. Well, 0 to any power is going to be 0, except for 1. 0 squared is going to be 0, minus 4 is going to give me negative 4. So when x equals 0, y equals negative 4, which gives me an ordered pair of 0, comma, negative 4. All right, let's plug in positive 2. So when x equals 2, I get 2 squared minus 4, which is 4 minus 4, which is 0. So when x equals 2, y equals 0. Okay, so that's going to give me an ordered pair of 2, comma 0. And then finally, let's plug in 4. That gives me 4 squared minus 4. Well, 4 squared is going to be 16. And 16 minus 4 is going to be 12. Okay, so when x equals 4, y equals 12, which gives me an ordered pair of 4, comma 12. Okay, so let's plot these 4 points so we can graph the function y equals x squared minus 4 that has a specified domain of negative 2, 0, 2, and 4. And finally, the graph here for number 5. This function was a little different, okay? The first 4 functions we dealt with were all in a straight line format. Now, it was only the scatter plot, okay? But the form was what we call linear, all right? In number 5 here, we don't have a linear function. We actually have what's called a quadratic function. Okay, so it's going to give us a U-shaped appearance, okay? So the function was y equals x squared minus 4. The domain was negative 2, 0, 2, and 4, okay? Which gave us these 4 ordered pairs, negative 2, 0, 0, negative 4, 2, comma 0, and 4, negative 12, okay? So when we plot those points, we get negative 2, 0 is right there, okay? 0, negative 4 is just down 4 units on the y-axis. Next ordered pair is 2, comma 0. And the final point was 4, and then up 12. Okay, so we're going to be a little bit off the graph here. Okay, so you can see kind of we've got this U-shaped appearance, and that's what all quadratic functions are going to look like. They're going to have that form, okay? So that's the graph of y equals x squared minus 4 with the specified domain of negative 2, 0, 2, and 4.